Yeah. Okay. The vibes are good. My wife has been saying that I need to bring back TJFT vibes to Novelty Search because it used to just be basically me and Ella, and the novelty was Open Tensor's Novelty Search, and we try to do it every 2 weeks. I need to bring back, and we just speak into the show about what's going on across the BitTensor ecosystem, which actually just meant really from OTF side. What have we done last 2 weeks? Where are we moving? What is this all about? Why does it all matter? And anyways, yeah, my wife told me, she said, you got to get back to that. That was really good. Speaking of that,
Yo, give me a second. Hold on. I gotta put my AirPods in because I just realized that. What's it called? Can you hear me?
yeah, you're loud and clear, man.
Nice.
See,
Um. Yeah. So we're gonna have to. First do it on my laptop, but then I'm gonna switch to my desktop if that's possible. Because we had Targon build our deck for us.
right. We'll go your phone, your laptop, your desktop, and then we'll live stream straight from the eyes of your robot.
That would be sick, man.
That would be sick.
Yeah, I'm actually at home
Cool.
today because I'm sicker than a dog right now. Slightly. Um, how do I?
No postponing. It's too late.
Yeah, no, we're not. No postponing. I wouldn't do that to us.
Nothing stops this train.
All right.
Yeah, you're good. We can see that.
You can see that?
Yeah.
Pretty
Really
cool,
nice.
right?
Oh, Josh.
Pretty
Hello,
cool.
Josh. Welcome to the stage.
Howdy, howdy.
Before you guys came on, I was just saying how I miss TJFT.
Where we'd all just rage for an hour.
The
Just
but
bull.
like the like the flat call where everyone could speak. That
Yeah,
was good.
those were the days, man.
Mhm.
But now
Let's get up.
there's like thousands of people who watch, you know?
Yeah, but we could get everybody on stage. Just
Yeah.
everybody puts their. It's just shit show. It was too much of a shit show. There was a time where I really wanted to go back to the TGIFT channel. It's still there. There it is, right beside us. And it's we couldn't make it work. Discord can't handle it. It's not
Yeah,
our fault.
you remember that you remember how people just like forget to mute, and so then we had to stop everything, be like, "Hey, dude, yo," and then like they wouldn't hear us, you know?
Yeah. In the background, you just hear like, "Mom, Mita." Okay. Mic chat from Josh. You're good to go, Carol. People are filling in here. We have slides. Do you guys want to just take it straight off the top? Just dive right in, and then we'll go into a conversation.
Yeah, we just kind of want to announce, and like let's kind of run through this, and then we can kind of open up to a conversation and whatnot. Thank you for inviting us on, by the way. It's been a really big week for us. We've been hard at work, heads down, um, trying to develop a great self-serve product for consumer applications. Um, Everything you're about to see was developed with or built with Targon as well, which is pretty cool. So like this slide deck's actually like a website, which is really cool. Um, but without further ado, yeah. So let's start off with where we left off last time when we were, uh, developing our last novelty search call. We've been live with trusted execution environments for 6 months now. Um, we this was a huge game changer for us in terms of what we could provide and offer. Um, in terms of stability, because we could now SSH into these virtual machines, confidential virtual machines that we had produced, and run the workloads ourselves. This kind of changed our uh, subnet. And you actually said something really great when we were in Singapore at the BitTensor event, where with BitTensor, it's all about constant iteration, constantly evolving, figuring out what works, what doesn't. You were speaking with the one of the first DPIN networks called Golem, which is crazy. I was actually super familiar with Golem, or aware of that project when you were mentioning it. And the issue that they ran into there was that it's smart contracts are super rigid. It's really hard to update and continue to iterate on this. And this is actually one of the great strengths of BitTensor. Um, and so, as we transitioned from more of a speed-based competition to competing around price, um, it was able to really increase our ability to offer a very stable product for our enterprise customers. Um, you know, we're handling an incredible amount of workloads, spinning things up and down for our customers, and we've made sure that this is secure, not just from ourselves, but also that you can verify this with third parties like Intel and AMD and NVIDIA through their attestation endpoints. Josh can actually speak a little bit more about that after the presentation, about the verification endpoint. I actually don't know if we have the docs out on that yet, but yeah, we'll talk about that in a little bit. We have fully encrypted support for Intel and AMD CPUs now. So this is a huge game changer for us because now we can support pretty much any kind of compute as long as it's like a recent generation. We can't support computers from like 10 years ago, for example, but like if you're running on a CPU server or a GPU server that was produced within like the last 2 years, um, it's going to support Intel and AMD. On the CPU side, there's a lot more caveats on the GPU side, but we essentially prevent kind of any people mounting things or all these sorts of things. Josh can actually probably describe this a little better in terms of exactly how it all works. I don't know if Josh unmuted there or not.
Yes,
Well,
I was putting in my earbuds so you wouldn't hear echo.
Okay.
Yeah. So any GPU is supported as long as it's in the Hopper series. Blackwell is slowly adopting compatibility. I think we're waiting on NVIDIA. I think what we've heard is about a month or two, and we should have the same level of support as Hopper does currently.
Yeah, and that's one of the really big unlocks for us, and one of the things that's really important to us is security. Um, as we've talked with customers and really gotten to understand their needs and use cases, it's become incredibly clear to us that you know we just simply this is something that we simply can't compromise on at all, right? If you can get into the container in any way, or we have several layers of security here, but like if you could if the host machine could break into the VM and see what the workload that was being run on there, that's just not something that is really marketable or palatable to most customers. And one of my big rules that I tell the guys all the time at the company is that, if this is a product that we wouldn't use, then we shouldn't be building it. And so I'm really happy that we've gotten to a point now where, I'm using our product every day. It's become really great. We used it for creating this slide deck. I mean, it's really incredible how far we've come in terms of our confidential virtual machine and the ability to be able to run secure, trusted workloads, or running trusted workloads on untrusted host machines. Um, we've been working very closely with Intel to develop next generation TDX features and optimizations. Um, stay on the stay keep your ear to the ground on this because we're going to be having a lot more interesting stuff coming out with Intel here shortly. We've learned a lot about what's coming down the road on Intel, and being able to work really closely with them has been hugely helpful in the development of our TDX VMs. Um, and so, our goal is that with working with Intel and demonstrating that we have a really secure product that, works with um, some of the largest or with most machines that are running Intel CPUs today. We believe that's going to give the Fortune 500 the confidence they need in order to work with us in our CVMs.
One quick
Now,
thing,
yeah,
real quick on the Intel stuff. Something that's very interesting. Some more of the technical people. Intel's interested in what we're doing enough to where they're actually letting us kind of steer the direction of some of the hardware level functionality they're adding into their chips. There are some features missing from the current ecosystem that we requested, and they actually told us specifically they were going to go talk to their hardware guys and actually get those features in there. So it's pretty cool to be able to work with Intel and even get some changes into these CPU servers.
yeah, exactly. I mean, these are the sorts of things that um, it's really building it when you forge your own path. There's a great Oliver, what is it, Oliver Frost? God, it's been a while since we read that poem in high school, but it's like the path less traveled, you know. Um, when you're going through the jungle, and having to hack your own path, it can be kind of difficult, but it ends up kind of being worth it, with all the experience and relationships that you develop along the way. Um, and we're really excited to be announcing and launching our fully self-serve platform for container rentals. We're working on VM rentals as well, but for now you can access the container rentals in the exact same way as if you've ever used RunPod or Liam or any of these types of platforms before, you'll be really familiar with how this works as well. Where you can run your own workloads on there. You can choose between 1, 2, 4, and 8 GPUs. We only support H200s right now, but a feature that we're going to be adding really shortly is the ability to virtualize those GPUs. So we'll have like turbo GPUs, for example, where we can combine two GPUs into a single GPU. Um, where, for example, like an H200 has 141 gigabytes of VRAM, so you can combine two of those into a GPU that has 288 or 282 gigabytes of VRAM. To simplify training loops and have to get away from sort of the distributed kind of workloads that you have to do, like PyTorch distributed and Slurm and all of these sorts of things. And also being able to fractionalize the GPU to where you're only paying for as much VRAM as you're using. So you can get the performance and flops of a H200, but pay a 4090 price. So you could have 24 gigabytes of VRAM on that card, but still get a lot of the features that Hopper has, like, for example, the transformer engine that's built into the chip. And so that we're really excited about this. You can go to targon.com right now and check this out. If you're interested, it's all self-serve. You don't have to interact with us at all. And this is our goal with this is that while we've been really mainly focused on working with enterprise customers, we really want to be able to allow anybody to be able to access this compute in the way that they wish. We also are releasing our serverless SDK today. I think that the repo might be private. We need to go open that up actually. But essentially this allows for the deployment of Python functions. You can run your own VLM instances. You can run web servers on CPU servers. Oh, that's actually something I skipped over here. My bad. On the fully self-serve platform is that you can also rent CPU servers. We have a large amount of CPU servers available on targon.com. And you can get, this is also virtualized so that you can have a wider range of different sizes. And we also support Docker and Docker. And with BusyBox and SysBox. So that you can get a VM-like experience inside the container. This is all live available right now on the Targon platform. And you can go ahead and use that right now. And with the serverless SDK, you can also run web servers, web scrapers. You can build a variety of basically anything that you'd like. You can run websites, for example, with our serverless SDK. And so that's all been pushed in live right now. And it's perfect for experimentation. One of our big customers is rapidly iterating A/B testing inference models, and so with this, they'll be able to create a whole cohesive pipeline going from uh, what's it called? Going from the input from the A/B test to fine tuning the model with the container rentals to then deploying that for another A/B test with the serverless SDK, creating a comprehensive cloud platform and a comprehensive cloud solution for our existing customers and hopefully for people on this call who are wanting to use it as well. Something that's going to be coming very soon, like in the next couple of weeks, is RDMA clusters and network volumes. So for our people who are doing pre-training runs, for people who are doing, very large scale, whether it's fine-tuning runs of a R1, V3, these very large mixtures of experts models, you'll be able to define these clusters with our RDMA supported nodes. That's accessible with a couple of different data center providers and miners that we're working with. Most of our miners are data center providers. I think that we have, most data centers. I think we have two unique individuals that I won't shout them out. I won't embarrass them, or call them out here on the call. But you know who you are. Who are doing a really great job of providing these types of hardware to our subnet 4 on BitTensor, and we'll also support multi-node network volumes, both on the serverless and on the container rentals or on the rentals platform. So if you have data sets, if you have model weights, if you have these sorts of things, you can have them connected to multiple containers at the same time for ease of use and making sure that your data doesn't get lost. So these are some really exciting features that'll be coming out in the next couple of weeks. So stay tuned for that. We've been really focused on the enterprise here. We've signed our first 12-month contract, which is proving our enterprise traction. We have a strong pipeline right now of Web3 and frontier AI companies with an active proof of concepts. And for people who are listening to the call right now, we're offering up to $100,000 worth of USD credits to eligible customers to be able to use the platform and determine whether or not Targon's the best fit for them. We have a lot of confidence that it is, but obviously, if you're interested in something like this, please reach out to Matt or Viraj or James and our sales team. We really want to highlight our strategic partnership with Dippy. We've been working with Dippy for over a year now, and they've been, kind of our first line of figuring out new products, new features. We're really grateful to them and for enduring maybe some when our product wasn't always in the best spot, and still hanging in there with us. We're processing millions of requests a day for them, and we're really happy to be working with them. And we're looking to not just do inference for them now, but also create an entire cohesive platform for them so that they can improve the customer experience for their 8 million users. We've also partnered with some of the largest data centers in the United States and Latin America. This has been something that we're really excited about. I've been particularly with some of these data centers, I've been a big fan and I've used their product for a long time. They have an incredible product, and this is something that really strengthens the ability of Targon and the subnet to be able to deliver a great experience for enterprise and self-serve customers. We have access to thousands of GPUs across 3 regions, with about 10 times, with about room for about 10 times more expansion on the CPU and GPU side. Um, and because of these preferred pricing and the markets that we've set up, this allows Targon to have greater than 40% gross margins, sometimes over 90% gross margins, depending on the exact product that they're using. Something that we did this last quarter, that we're really it's proven to work really well, is creating an order book for interruptible compute. So fundamentally, Targon is a right now on our subnet, we have an interruptible compute market. And so what that means is that at any time a node provider can pull that node offline. And that's and what's it, we've written a lot of software and created a software solution so that we can offer an interruptible price to our customer with an uninterruptible experience. This has been the first truly transparent order book matching the sellers of the compute capacity with our incentive mechanism. Um, we are with spot 1 month, 3 month, and 12 month futures markets are coming in Q1 of 2026. We're really excited about where that's going to be allowing this, and this allows basically price discovery of these markets. If you want to know how much a 12-month contract for 64 H200 nodes is, you're really it's back for there's a lot of backroom deals that are going on. It's very much who you know, how you know them. And so, because there's not transparent pricing around that, it's not really a free market. This is something actually a little anecdote to give here, a little sidebar. I was arguing with one of these 16-year-olds who's like, free healthcare and all these sorts of things, like, oh, the government should pay for healthcare, regardless of whether or not where you line up on that, right? In the United States today, if you want to have a kid at a hospital, how much does that cost? Right? You don't know. If you call the hospital, you say, I want to have a kid, how much is that going to cost? They're not going to give you an answer. And it's not like having a kid is an emergency thing. Like you know roughly when you're going to have the kid. And so the fact that there's not transparent pricing on healthcare in America demonstrates that it's not a free market where the consumer has choice to be able to shop around on those prices, which means that that market cannot be efficient. It's not a free market, and that it contributes to a lot of cost increases in cost, which hurts the customer and the consumer of that at the end of the day. And in the same way that the healthcare market in the United States is highly inefficient, the compute market globally is highly inefficient as a result of this. And so one of the things that we really want to do is kind of sort that out to where you can get to know what the interruptible price is, what the 3 month, the 6 month price is. And something that we're really excited about that we'll also be releasing here is compute derivatives and stable coins around this, a lot of financial derivative products around this. This is something that is, we think, a huge market for us, a total addressable market. Over $1 trillion market that can be addressed. A lot of the financing deals around these compute deals right now, they're done through SPVs. They're highly financially engineered, and so being able to offer a permissionless way of using those derivatives and also having a way to pay for this compute outside Targon's incentive mechanism, is really going to expand the number of nodes that we can have on there. And it's something that we're really excited about. To wrap this up, we've also been supporting a lot of academic research. We've been partnering with a lot of universities to provide secure compute, and clusters and these sorts of things. We've been supporting Zed, for example, who is going to be releasing some papers at ICLR. If you're an academic researcher and you're looking to get credits for your training runs and whatnot, or your fine tuning runs or for your research, this is something that's really near and dear to my heart. As is someone who used to do a lot of this type of research. I still do a lot of this research, but it's very much on my own time. And so if we've been supporting a lot of these people, and these researchers, when it comes to compute, and hopefully, with our new platform design with serverless and compute rentals in a self-serve manner, it will allow them to accelerate the rate in which they're able to do their research. They won't have to reach out to us at 2, 3 a.m. and say, hey, can I get another node in this way, or in these sorts of things. And so these are we're really excited to continue partnering with these researchers and continuing from there. So that's been the presentation. Thank you guys so much for listening and partaking in this. And let's open it up to questions from Const and
Yeah.
from the
Whoa, whoa,
community.
whoa. This isn't over yet. That was just the appetizer there, Rob.
Yeah.
Um, the novelty search
Do you,
was totally off the cuff because 3 days ago we had a team drop out, and I just said, hey, Rob, can you come up, and you guys are having a pretty busy week, right? That this launch was happening, so it felt like the right time. Um, so just be clear, everyone can go to targon.com. Anybody in the world can go and rent a CPU server and a GPU server, and there's even serverless, correct?
yes, and we have the serverless SDK. I haven't we need to make it not private right now. I believe. Hold on, let me go to the
But things are
um
things are rolling out. I mean,
yeah.
but you can get a CPU server, which was incredible because it was the day that we had the dropout, and the reason we brought you up was because selfishly, I actually just needed CPU servers, and I was using AWS, and AWS is really just a what do you like, EC2 instances, IAM users, SSH keys that are like archaic, like everything's slow. There's just too much information. I just want a CPU machine. And I went on GPT and I was looking at all these providers. You just sign up, and they're all just stuck in the past. Like, I just want basically one click. Put some money in, put some Tau in. That's fantastic, and then I get a machine that works. And you were like, you should use Targon, and then it was just the easiest thing of all. Like, it was of all the products that have existed to sell CPU servers and GPU servers that are out there today, the actual easiest is running on an incentivized network
Permissionless
and
as well.
a permissionless network. And just like to think, and which was mind blowing. But the fact that I just went to use Targon because, and it actually worked there. I had like I don't know how much that like Threadripper would be if I'd rented it on AWS. I got the beast of the beast CPU machine. That would be like $10 an hour, maybe more on
Yeah.
AWS. Like the prices are insane for CPU servers. And sometimes you just want a CPU. You don't care about having or paying $26 an hour for B200. You just want something that works. Um, and so we have been using your machines a lot, which was really incredible. I mean, like there's some rough edges here because you were just launching that week, but this investment that you've made into TEE, um, I think is incredibly revolutionary for BitTensor and the entire DPIN world. When I mentioned DPIN sorry, when I mentioned TEE to the guy at Gollum I spoke to at Token 2049, um, he just didn't even believe it was possible. That's
Yeah.
how most people react to the concept. And yet it sounds like there's been incredible innovation, not just from your side, but all the way down the stack. Intel, right? There's papers being written. Nvidia is building the chips. Like the field itself, the whole industry is pivoting itself towards working with a tested compute, and it just falls just perfectly into your lap. At this moment in time. Oh, great! And on our lap, really a BitTensor because we do verification. We love verification, and we need to know that people are running particular machines, and we know we need to know people are running specific software, and we need to know that it's private. And this base layer I didn't kind of believe it was going to happen, but now that now that I'm actually running a couple of your machines in trusted execution environments, it's kind of incredible. And I've been going around to teams, the last couple of months and basically telling them, um, once you build your product, you build an incentive computer that optimizes this particular thing, and these RL environments are going really fast, and they're like, well, how are we going to monetize this? And I'm like, well, once that's done, just go throw that out, put it into a container on TE, and then you can go to a customer and you can say, look, this is like verified, serverless, um, auto scaled, and totally private. We can't see your data.
Yeah.
Nobody can see the middleman here. There's no middleman sniffing the packets, and we can prove that to you potentially because we make you a direct connection. And we know that they're running this process over here, and all of a sudden you become um, not just kind of like a cool decentralized, oh, let's just soak up compute from the rest of the world and provide it. You're actually able to give assurance to, as you said, Fortune 500 companies that no other team in the world. And so you're at this sweet spot where you have a product that works, people can come in and people can use it. And then you can give assurances, you can shake hands and make a deal with somebody that can tell their superior, tell their, whoever they're working with, and even their customers themselves that everything is going to just work, lock and key.
And the music to those people's ears as well is that we can do it at the best price because of the incentive mechanism on BitTensor. It
But tell me
essentially, it's a force multiplier, you know. So I'll tell you a little bit about it. Right now, we have an interruptible compute market. Some other compute subnets on BitTensor have faced this before, where they'll rent out the machine, but that node will come offline for whatever reason, right? Maybe it goes offline because there's a power outage. Maybe it's because they've pulled the machines because for some other reason, right? And so obviously you have a bunch of angry customers in that situation. Now the answer to that has been collateral, and it worked. The collateral has worked really well, and we've seen from on those subnets an incredible increase in uptime, which is great. I mean, this is something that we love to see this sort of thing. And those subnets have been really pioneering the forward on those types of innovations. Now on our subnet, um, we obviously we'd face that same issue, right? If a node came offline randomly for whatever reason, we were selling that to a customer, that would be an issue, right? So what we did is we wrote a comprehensive orchestration platform on the back end of this that allows us to ensure that the customer itself doesn't have any downtime, um, with even if a node comes offline or two nodes or three nodes. Now, I'm sure you're wondering, well, what if all the nodes came off, right? Well, then yes, we would start having some problems there. And that's why it's really important for us to start building out those 1 month, 3 month, and 6 month markets
Well,
as well.
we'll
Um,
just make it some redundancy on Rob. I know that you're pushing towards some clones, so that's how we'll.
yeah, exactly. And it's been a big push on building out this order book and really trying to find the best price. Like, what is the true price? Like, this is something I think about all the time. Like, what is it really when I'm getting into a taxi in Singapore, right? Is it really $70? No, right? Because when I'm coming back from the Marina Bay Sands, it's the that guy's offering me $9, but because there's like this cabal of taxi drivers at my hotel who have worked together to corner this market to increase the price. Right? It's something very similar is happening in compute right now. It's quite nebulous. Sounds like a conspiracy. I promise you, it's not. You can read all about it, or if you've used compute before, you've rented compute from a broker. I'm sure you felt it. Or it's like, oh well, this broker's offering me $2 and this one's offering me 240, and it's like, oh, but this one's over in this region, and it starts getting very complex really quick. And so one of the things that we want to develop is sort of like a phone number for compute. And this is something that we've been working with the hardware manufacturers on, where, back in the day, and I mean, it's still this way today, but not necessarily. Back when phones were just landlines, right? The phone number would tell you exactly where the line was located. And so for AT&T or Bell, it was Bell back then. It was really easy to do repairs if a phone line went down, something like this. Oh, well, we know exactly where that the physical line is located. And so we want to develop these same sort of, phone number QSIP-esque numbers for these compute providers, so that then when we create these permissionless markets on top, whether that's the interruptible 1, 3, 6 month kind of markets for this, right? We know exactly what a node in India is worth. We know exactly what a node with RDMA in Iceland's worth. And you're going to have a lot of support. And what's really important is developing this self-serve platform is really important for creating additional derivatives on top of that, right? If we have $1 billion compute market, right, well, now we can create these derivative contracts on top of that to increase the value to $100 billion. And so this allows for a huge unlock for the suppliers of the compute who are building out these data centers, who are, Elon Musk wants to spend $20 billion on his Colossus 2 data center in Memphis, right? But let's say, they're not going to be training for 2 weeks. They'll be able to come online and put those nodes on the interruptible market, because they're earning $0 on that, like they're not making any money. And so if they're going to get paid 60 cents, 60 cents is better than $0. And so, it allows for optionality. It allows for when these data centers are financing this compute, we really want to become the preferred option for them when it comes to, they can just tell the bank essentially, oh, well, even if we aren't able to get a customer, we can go put it on the interruptible market.
Right. And the attestation is really the core component here, because without that attestation, it just makes everything easy to price, because you can see what memory. What are the things that you can see, Josh? And to take us through, you explained this to me once on a call before of how this TE works, and I know it's sort of like a secret sauce. Yeah, it's like this mythical thing. What the
Yeah,
hell
pretty
is
much.
what the hell is happening?
Sure.
To allow, it just seems impossible. What you're producing a cryptographic signature of the infrastructure of a chip?
Kind of. So inside of these AMD chips or Intel chips that have the SEV or TDX compatibility, they will have some sort of key. I'm not sure if it's exactly like a literal like crypto key or some sort of secret information that is baked into the actual chip itself, to a point where per Intel, per AMD, whatever this secret thing is can't even be read off of the chip if you owned the hardware and had it in your lap. Like these things are burned into the actual chip itself. That is what lets us essentially build these virtual machines. And when the virtual machine's online and running, you can call this attestation process, which essentially says, hey, I'm going to send you some data. Can you sign this with that secret data that is burned into the chip? When it does that, the big reason we're able to do any of this is part of that process, when you call that function, includes metadata about the process that's running. So when I say, hey, give me an attestation with like this data, like let's say it's user data or whatever, when it gives me the report back, it'll not only say, okay, here's the signed payload that you gave me with like your user data, but also this is verifiably also signed information about what process called it, what were the flags used to start this VM, like all this sort of metadata that we can then use and compare on our infrastructure to make sure, is this the exact VM we expect to be running on that specific machine? Is it secure? Is everything working properly? Are the GPUs configured correctly? We can see virtually all the information we could possibly want inside of these attestation reports.
So you can guarantee that this attestation is what you're running, and then you can check anything you want, right? You can check the
Yeah. So
bandwidth.
the user the user data is pretty flexible. So the idea is you have one thing you can call that verifies, again, everything that we do is running inside these VMs. So once you've proved for sure that the VM is secure, if you are inside the VM, you can trust anything that is going into the user data of the attestation report. So for instance, say I wanted to check a node's bandwidth, right? Well, then I would SSH into the server if I was doing this manually per se. You could go to the server, run your bandwidth report, right? So you have this data that you've collected inside the machine, or so you're scripting this in some startup script, whatever. It puts it in the user data of the attestation report. So you're not necessarily like doing anything cryptographic on the actual download speed, but you know that because the downloader ran inside the VM and is in this attestation report, because the only way it can be in that attestation report is if you are inside the VM. When we get it out and we verify the report, we can know whatever data is in there is trustworthy. So, for instance, for checking like what GPUs are running inside of a VM, we literally just do NVIDIA SMI, and then you just take the output of that, shove it into an attestation, and then send it all the way back. And then we can say, okay, yeah, it looks good. And even more than that, we actually run NVIDIA SMI and then also an NVCC check, and then all that goes inside the attestation report. So not only are we checking an attestation report from the CPU side of things, if there's a GPU on the system, we'll also check with NVIDIA and make sure that the tokens for the GPUs line up as well. So it's kind of like doubly attested.
So the attestation on CPUs is where this began, but now it's spilled over into GPUs as well. And so both those chips provide this service.
No, not quite. It actually started the other way around. We started with the GPUs doing the NVCC stuff. And then once we were able to crack the CPU side of things, we were able to build these encrypted virtual machines and all that.
How do you guys know that when you query to a machine, you get this attestation, and then you're like, great, thanks, man. That sounds great. You have lots of bandwidth. Wow, you have like 5 million GPUs. All right, whatever. And then you give me an IP address and ISSH, and there's nothing, and they just provide a different endpoint. How do you like stop that sort of relaying from occurring?
Sure. So we have a couple of other tests that run outside of attestations that will essentially verify that that node is where it says it is, but also included in the attestation report, or maybe not in the report itself, but in the part of the process that we query all this stuff, the node itself will actually report where it's coming from. And so if there's a mismatch there, we'll know.
Okay, understood.
The only way for I can explain a little bit how it works actually. When the VM first initially starts up, in order for the virtual machine to decrypt in any capacity, it actually has to pass an attestation report before it even boots itself up. So there's like an initial unlock period. When it first does that unlock, we'll save the IP address for that node for that VM, because every single VM that a miner runs is totally unique. We generate it on the fly per miner per node. So once one of these VMs starts up, it is hard locked to that IP address. So if somebody tries to move it or they claim it somewhere that it's not, it will never ever work. Once the node is booted up, it is hard tied to that IP address, and we know from the second it turns on where it is, how to reach it, how to make sure it's running securely. And if it's not, and it doesn't prove itself to us that it is secure, it will never be able to even finish starting up.
Josh, take me through the process of like how I would mine with a CPU server. It sounds like there are some limitations. You need this type of chip. You need that type of chip. First question is the world moving towards basically everything is going to be attested or potentially attested, so that like my MacBook could be attested or any software could be attested? Or is it just these special like high capacity chips, modern, best in class? Or is there a way to take previous chips that have been around for years and make them like upgrade them so they have this quality? And then finally, like if there's these limitations, if there are limitations, how do we not just get killed on price because other mechanisms for incentivizing computation from GPU to CPU can really pull in more quantity?
Sure. So there's a few things here. So
hold on. But on that last one on the price thing, let me answer. So you can go ahead, but then on that last question, let me answer.
That's fine. So first of all, if a CPU or GPU does not have attestation Like if it can't do it right now, there won't be a way to upgrade those chips because again, this is stuff that's burned into the actual die itself. It's not a software thing, it's a hardware thing. And if you think about like what it's actually doing, that kind of makes sense. Because if there's a fundamental problem in compute where if I have computer A and you have computer B, how can computer A know for absolute certainty that computer B is actually running what it claims to be running? And that's the initial problem we went out to solve. And when you start getting into the weeds of it, if you are just looking at a software level solution for this, it's virtually impossible because at the end of the day, computer B is going to have some secret that it owns that you can verify that they're doing what they should be doing. If they don't have that, you can't prove that. But if it's something baked into the actual hardware itself, where not even the owner can get access to that, then that's your point of trust. That's what you can actually trust. So in order for these things to work, they're going to have those chips. Now, on whether, so there are a few things here. So first is most CPUs and even the newer series GPUs from NVIDIA looks like the market's generally moving in the direction where all chips will essentially have this capability. Now, does everybody need to use this capability? I don't think so. BitTensor creates a unique problem in that we have this not only highly untrusted compute, but completely anonymous compute. We don't even know who these people are that are bringing this compute onto the platform. That's the whole reason you need these encrypted VMs. If I'm going to someone like Amazon, the only reason you would use a TEE is because it would be for the reason that you don't trust Amazon to not look at the data that you have in your virtual machine or whatever it is. If I'm a data center and you're coming directly to me, there's not really much of a point of using a TE unless you're very afraid of that data center themselves snooping on what you're doing. It really applies specifically to the scenario when you have all these untrusted people trying to participate in this ecosystem, and you need to be able to trust what they're running on their machines. Now, something that I've been thinking about that's kind of interesting to me is if we get to a place where this type of solution can be kind of consolidated down, because right now it works really, really well for VMs. But I think on an application level is still where things get tricky. An easy thought experiment is say you have something running on it's a little web server and you have it running on localhost 3000, whatever, and you have it running in a TEE. Well, it doesn't matter that it's running in a TEE because I don't trust your environment in the first place. So if I can SSH or if I have a CPU server, right? And I'm in my CPU server and I run a Docker image in a TE, I'm still the one running the Docker image. And you can't prove from the outside that the Docker image I ran on my computer is the one I actually claim it's running. So I can run a little web server that has my malicious code inside of it. And then when you ping my localhost 3000, I can trap your message, I can middleman, I can do whatever I want because I'm in the actual machine. There's no encryption going on, there's no secrecy. It's just, sure, it's running in a TE, but the only thing the TE is actually protecting against is the data center owner, not the person who owns the actual machine. The only way to do that, and what we've done, is you actually encrypt the actual virtual machine itself, so you can't even get into the software part of it. It is totally blocked off from everybody, the hardware owner, the rental owner, no one is able to touch these things at all. If anyone has any access to any level of that, everything goes out the window. Now, what will be interesting is in the future, if we are able to get to a level where you can prove via attestations that a specific process is running the exact way you expect it to be, I think there's going to be some really cool innovations and stuff like anti-cheats, where essentially a game maker can say, okay, I have this game, and in the game itself needs to be run on a computer with an attestable CPU. And then while you're running the game, they will actually query you for these attestation reports, making sure that you don't have a hacked client going on or there's no third parties messing with anything, whatnot. I think that's directly applicable to the entire gaming industry, honestly, and would be something that would be very, very cool to see. But are we there yet? I don't think so. I think there's still a lot of things that need to be figured out and worked on, but is somewhere that I see this slowly evolving to.
Yeah, as you can tell, we take security very, very seriously. We've thought this through, and we've also, we compare ourselves to our competitors, right? We look at the products that they're offering and compared to the product that we're offering. And the to answer your third question about price, we can do a lot of software. Essentially, we're a pure software company, right? We only focus on the software side of things. And so we can develop a lot of software that helps us, be able to virtualize the GPU, for example. We
You're a
can,
pure software hardware company.
well,
We build software on hardware.
yeah, we build software on hardware, but like our expertise, my point is that our expertise is on software and understanding these types of problems really well, particularly on, this unique challenge of uh, malicious miners trying to extract data, right? On most other, permissionless networks that we've seen, right? It's very easy to break in and see what's going on in there, right? Um, you can go and see the types of workloads that are running and potentially even get user data out of there. Like, for example, like if you're using a permissionless network to mine another network, right? It's very likely that the host machine has access, can use a bunch of these different solutions to break into the container or break into the virtual machine, and actually see what you're doing. In fact, this is something that we're so cognizant of because we just to be frank, I mean, we have PTSD from these miners, right? I mean, like, these guys have terrorized us at 3 a.m. so many times. I can't even count, right? And especially over these last 6 months, I mean, we've been able to really kind of relax in terms of, oh, we know that the like these basically nothing the miner can do, right? There's nothing the miner can do to actually break in and steal this information that we're running for these customers now that we have these encrypted VMs. And so if they're able, for example, like, if a customer wants to go onto another platform because, for example, we can't support 4090s because we know that we can't protect the CC on the GPU, on the confidential computing on the GPU, right? So that means that the data center, the host could dump the GPU memory, right? Like that's something that we're just not going to do. But what we can do instead is we can virtualize that GPU and sell it to you at the exact same price as a 4090, give you 24 gigabytes of VRAM. Oh wait, you're running on an H200. So now you have the transformer engine. We can scale up the flops but keep the memory the same. So we could give you a very powerful GPU in terms of the number of flops that you're getting, but still limit you at that 24 gigabytes of VRAM. And so we can create, and we have a lot of software around this that allows us to offer a truly incredible customer experience, which is our main priority, right? Like we are a customer obsessed company, and so if a customer is telling us that we have a problem, or that they're considering switching to someone else or something like that, we'll work around the clock for them to build the features that they need in order for them to have success in their own business.
The fact that you guys, and I started when I was just mentioning a second ago, like the fact that you guys can provide a service to me that is better than AWS is really what, you're pushing up the margins on what you can make from this compute. And I think that perhaps we've never gotten to that point, um, where we can provide a service that's just high fidelity, right? Like I'm going to use this computer. It really works, and I know it works, and it's private. You guys might argue that the service that you provide is almost always going to be better than a centralized provider.
Exactly, because because of the permissionless nature of BitTensor, because of the incentive mechanism and the incredible work of over years of development with the BitTensor network, it allows us to have these data centers really compete on transparent pricing, which means that the customer wins, the consumer wins here, right? If you go to
Mhm.
Amazon, Amazon doesn't really have any pressure, right? Maybe they're competing against Google, but they can work together to fix their pricing, for example. And this is kind of what we see, right? I mean, I don't want to sling mud at them or anything like that. That's not what I'm trying to do here. I'm just trying to say that we've seen time and time again, whether it's on the micro level, like the taxi example that I experienced last week, all the way up to the, hundreds of billions of dollars in terms of market cap companies, right? That this is something that happens time and time again. And because Targon was forged in this sort of this network where the miners are being paid to break your stuff, right? Like they're incentivized to do it. You know, we haven't had an exploit in God knows how long. I mean, I can't remember the last time we had an exploit, right? We're very calm now, and that allows us to focus. Instead of being in a tizzy on trying to patch this hole or patch that hole in our subnet, we get to focus on developing the best customer experience that we can.
Wow, I'm so disappointed in the miners on Targon.
Yeah. Well, you just make it to where that you just there's nothing that they could even think of doing, right? Like there's just no option for them to exploit it at all, right? And I mean, you think about when we first started as a subnet, right? I mean, our solutions to the miners were maybe exactly the opposite kind of thinking that you'd want to do. And now from that lived experience and that post-traumatic stress disorder, that we've experienced there. It's really allowed us to, you know, not only are we required to constantly ship. There's a saying that we say, it's like, it's not yours if you can't keep it, right? And I feel like a subnet on BitTensor is very much that way. It's not yours unless you can keep it. And so even if you're in the top today, if you don't go out there and bust your ass every single day, then you're not going to be in the top anymore, right? Because there's this constant competition that's occurring. Now, I could say, like, yeah, maybe we should treat each other with kindness, right? Maybe we should be sportsmanlike, these sorts of things. These things are really important, right? But also that competition factor is what ends up giving customers and consumers of these products the best experience possible. It's what pushes the world forward. It's how we get all of the technology that we have today. And TEE is one of these, frontier types of examples where, yes, I mean, right now it supports a limited amount of hardware, and hopefully in the future, all hardware, even the consumer stuff, will support it. This is something that we've talked about before, where it's like with anti-cheat, for example, the solutions for the anti-cheats for a lot of these video games. I mean, we're essentially an anti-cheat company, right? Like we make our own version of VAC, or what do they call the League of Legends one, the Vanguard? Which Vanguard's basically just a rootkit on your computer, right? Like, imagine if you didn't have to give up security or privacy of the files on your computer in order to run this anti-cheat, right? And they could really prove it. I mean, this is where this technology is going over the next 5 to 10 years, and it's really cool to be here, developing it for and creating a better customer experience out of that.
It was never about AGI. It's always just been about making video games better. Um, um, like as you're speaking there, Rob, like there's a lot I'd like you to just rant about. Like take us, like let's all sit back in our chair and grab a mapacho or a cigar and light it up, and tell us about all of the iterations of Targon, like Subnet 4. Like how many, because it was Sybil at one time. It was an inference provider, correct? Like what is the timeline here? Like how did it start? How did Subnet 4 start for you guys? And like it's been a bumpy road. So like take us through.
Yeah, so it's actually funny. We've kind of come full circle, right? When we started out, in October of 2023, we really wanted to develop Sybil. Sybil is I get the name from the Sybil system, which is from an anime I watched as a child called Psychopaths. Essentially, it's basically Singapore. Like it I don't know if anyone's never been to the Singapore airport. It's maybe the best airport on the planet. I've never been to a better airport. I'm a huge aviation nut. And you just walk in, they scan your face, and you're good to go. Right. And if you potentially stole a robe from your room, they pull you over to the security line, right? Because they know. It's incredible, right? And so um the civil system in the show is this essentially can see the future. It's like Total Recall, if you've seen that. And so this was the original idea that behind Targon is that or the subnet 4, it wasn't even called Targon at that time. And I realized that we started out just doing like very simple LLM inference. Then we were like, okay, well, it'd be really cool if we could like do search, right? So like you could get the like if you want to know what the weather's going to be tomorrow, or you want to know, it was very similar to some of these prediction subnets that have formed today, but it was all through LLMs. And so we were building and developing and iterating on Sybil, but the thing is that it's really hard to verify whether or not a person is actually running the LLM that you want them to run. And so then we were like, okay, well, we need to develop a verification mechanism for inference. And that's what was the kind of original iteration, or the first iteration of Targon, or second iteration of Targon, doing that index 0, index 1 stuff. But so then we developed that verification, the redundant LLM verification mechanism. We continued iterating through there. There were a lot of problems with doing that, right? Like it's not a simple thing, because essentially, depending on what GPU you're running it on, what your seed is, all of these different sort of things, there's just a lot of non-determinism in there, which makes it very hard to get the same output from one machine to another. They give different outputs. And so that was a real trouble in itself, right? It was, it feels like an impossible problem to solve. I see people claiming all the time that they've solved it, and I'm skeptical. But listen, I like thinking machines. I think the ex OpenAI CTO claimed to have solved it the other day. I looked at that thing for 2 seconds, and I'm like, they're not even talking about GPUs here, right? Which is where a lot of non-determinism comes from. And so it's we just realized there was a lot of problems. And so then we were talking, I think, like November of last year. There's also another really big problem with just verifying inference, which is that, like, okay, well, you want to sell that to a customer, but the customer doesn't want this miner to be able to see what they're saying. They want privacy there, in the same way that they would get the privacy from AWS or any of these traditional data centers, Web2 data centers. And so, as we with Dippy, November of last year, this was something that we kind of realized, like, okay, well, this maybe is not the best path for doing inference. And so, with redundant deterministic verification. And so, November of last year, we really started investigating this technology, and we released it in April. Right after we got on OpenRouter and these sorts of things. And there's just so much work involved in building all of this out, particularly because no one's really done it before. So we had to really innovate and come up with a lot of the solutions on our own. And we built a pretty good enterprise inference business here. I will say consumer inference is maybe not the business to be in. I'll just be honest, right? Maybe in 5 years, when a lot of these these people who are giving it away for free, and at prices that just don't make sense, it's unsustainable. It won't be able to go like that forever, right? And the consumers are so price sensitive as well. Like, as soon as you up the price, they go to another provider, because then the provider's like, oh, well, I can go juice my bags with my investors, right? Like, there's a lot of issues there with the consumer inference side. With the enterprise side, right, it's much better deal, I think, right? You can work something out. You can really focus on one customer and give them a really great experience, instead of dealing with like 10 Russian people yelling at you in Russian, right? Like and so we still do an inference business as well. And we're actually opening up a self-serve consumer business here soon, as a rebrand of Sybil.com. So stay on the alert for that. But we've really kind of opened it up now. We really focused on enterprise to make sure that this product was good and we could iterate with the enterprise. And now we're at the point where we know the security is battle tested. We know that a lot of our software is battle tested and is going to work. And now we're ready to open it up to self-serve consumers, to where hopefully the consumers don't have too many issues, or too many fires to set out, and it just kind of runs itself. So we're really excited about this next chapter of where we're taking the subnet. And yeah, I appreciate Jake. I love to rant, so I can just talk forever.
We like to listen. So there's this other aspect of privacy. You guys could create maybe one of the first truly. What was it? Matthew McConaughey, right? Was talking about having his local model working with his notes, and it kind of blew
Yeah.
up, and people were like, oh my God, doesn't he know about running your own GPU? And there was some pushback on that, because it's kind of like it's very expensive to run a B200 in your living room, especially 8 of them, if you want to run a really good model, and that's what people need. So obviously it falls back to inference provision on the cloud. but then we lose privacy. And if it's GPT or it's Google, both those companies are known to collect data and potentially even give it to the feds. Um,
Yeah.
could you build a product with this where there isn't like as I understand it, there is kind of a pass through to Targon servers and then the network, but could you build it in a way that there's just a direct connection from me to an attested environment running some model on some GPU, and you can tell me and I can cryptographically prove that yeah, this is my machine when I need it. Like serverless inference, and I pay as I go, and I'm guaranteed to get the model that I want and the service that I want for in a private way.
Yeah, no, it's totally possible to build. It right now there is one still there's still you still have to we offer a terms of service and a privacy policy. So we give our guarantees as well that we're not going to store and do these sorts of things. We're not really in the model training business, so there's not a huge incentive for us to do this. Um, but it is something that we have talked about and we have thought about where it's like completely end to end, even where you don't even have to trust us and you just go straight through the subnet. Um, there is some things that we'll have to innovate on there in terms of uh, like actually developing that out. But it is certainly something that we want to build and we're working on. Now, to give your Matthew McConaughey example, it's very hard to run 8x B200s in your living room, and that's totally true. Not just the you might burn your house down. That's probably I'd be very careful. In fact, I have a friend who he hits me up the other day. He's like, "Hey, I'm trying to buy some A100s," and I was like, "Oh, well, what you need to do is you need to get you pick a great data center. Make sure that they're not too expensive on the colo, and that they don't lock you up in these super long contracts. You got to make sure you got." 10 kilowatt strips on both sides. You need 20 kilowatts in total. Make sure you got your cooling, all this stuff. I just started going down the list, right? And he was like, no, 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 man. I want to buy a like beat up A100 box and I want to unplug my washing machine and plug it in right there. So you get the 240-volt plug. We're all Americans, by the way. So that's the Europeans and the Asians. They have it better than us. But uh, I told him, he's like, oh yeah, so I'm just gonna do this in my living room. I'm gonna remove my washing machine and just plug it in there. And I was like, well, man, I'd be very, very careful with that, right? Because myself, when I was a kid, I didn't really know much about power, and I was trying to do this. I had this like 240 to 120 converter that I'd plug in the outlet. Anyways, I ended up burning my mom's garage down. So it's not super practical to do this stuff at home, and you know this is really why the serverless SDK is something that we're really excited to get out there, because it's going to allow people like Matthew McConaughey to be able to know for sure that at least on the actual GPU side, the data center side, that none of that's being logged or saved or anything like that. Because we give our guarantee and we also can allow you to hit the verification endpoint, so that you can also verify that the workload that you were running actually ran inside this confidential virtual machine. And there are some providers, that inference providers that we're working with, who have said that their policy is well, basically, if you don't own the GPUs yourself, then we're always going to put this tag on you that they're saving your data. That feels kind of bad faith and not fair to us, but it's also not the best business to be in the first place. So it's kind of a no lost love there, obviously, but I do think that's something, really building out something completely end to end is something that's super interesting. We want to do.
Um, Before we go on, Matt, head of growth, he's probably listening to the call. Matt, can you try to get Matthew McConaughey in on the next novelty search for Targon?
Yeah, yeah. We're probably gonna see him next week.
So I have been intentionally going to all the UT Austin games front row just so I can nurture my relationship with Matthew McConaughey. It's coming along nicely.
That's what I like to hear. That's what I like to hear. That's good. Okay. Let's talk. You guys you're running these. And this is more of like in the hot seat question, Rob. And we've talked about this privately, but I think there's a lot of people that are concerned about, you know, how is Targon going to bring back the revenue from this fucking amazing product, these contracts that are going through the subnet owners, and like I want to talk about this like sort of abstractly, like how you think BitTensor can make this relationship between the token, the subnet token, and really the team that's running. You know, you have people like Matt that go out there, you know, working on sales, and you guys are making revenue. How do you see that connection going forward? And what's your plan in the near term?
So, you know, obviously something that just to say this part, right? Something that we really want to build is a network in which, you know, we have a really robust tokenomics for other providers as well. In order to build a $1 trillion compute market that every single data center is plugged into, we really need to have buy-in beyond just ourselves. Now, we're really demonstrating what's possible to do with these confidential virtual machines. And if you had enough stake weight on our subnet, you would be able to create your own confidential virtual machine, and then deploy that to one of the miners. This is where we really want to build to that. It's something that I think is not just important for the subnet and its future, but also for kind of BitTensor as a whole and all of crypto, right? You know, making sure that we have sort of unfettered access to these compute primitives is something that I think all Web3 companies need. Where is Uniswap running? Where is where are these base operators running? You know, the Ethereum validators, all these people, right? You know, they're probably running on traditional Web2 companies, and we want to be a sort of native solution for them. In the same way that Aave is a native solution for getting loans, right? So this is something that we're really it's on the roadmap. We're thinking through. As you can tell, we think things through very, very deeply and make sure that it's secure, because security is one of our number one priorities. And making sure that it will work not just for 6 months, but for 1,000 years as a part of this 1,000 years intelligence federation. Now, when it comes to revenue and buying back, we did have some customers over the summer who were paying us in Tau, and that made things very easy for us on the tax side because we can claim creative property. Oh, this was just passed through. We didn't actually basically we were like almost like a payment processor, like a pay. You know what I mean? Where it's just it just flowed through this wallet that was controlled by us and run some software to buy back, but it's not like actually owned by us. And that part of the argument is really clear with the IRS. As for I know I've said it several times in this call, but we are Americans. Everyone on the Manifold team right now. And so when it comes to fiat payment, it's a little different. And the reason why is because you gotta it goes to the Stripe, and then it goes to your bank account, and then you got to go back to an exchange, and then you got to do all this extra stuff. And so it's like at each step you're getting taxed and fees, and so a lot of that is something that we're really trying to work out with our legal team right now. The current administration in the United States is quite crypto friendly. They're very open to these types of solutions to create robust on-chain businesses. And so this is something that we don't want to just solve for ourselves in terms of legal precedent, where we have to get into an argument or a fight or a lawsuit or something like that. We're really trying to avoid that. And so we're really trying to develop a comprehensive solution there when it comes to fiat-based payments, because we obviously want to accept any kind of currency, right? If you want to pay us in Singapore dollars or Singapore slingers, we want to be able to accept that. And so,
Slinger, that's a cocktail.
yeah,
The rap, by the way.
yeah.
So is Targon.com supporting that kind of pay link?
Yeah, so we support both Tau and fiat payments right now. And with the fiat through Stripe, you can pay with any kind of traditional fiat currency, that's issued by a government. We're also working on being able to accept USDC and these sorts of things. 30 Subnet 10 is actually developing a solution for the stablecoin side of things that we really want to integrate into our platform. And so, we want to be able to support everything, almost like a smart contract, where it's just like, no matter what the currency is, it will just convert and automatically do this, where it's a completely automated process where, because something that I think about all the time is like, okay, well, what if me and the Manifold Boys are, on an aircraft going to, an away game, a UT Austin away game, and then we get struck by lightning and the plane goes down, right? This is a real concern. It needs to be resilient in this way. And so, we're really trying to work through a lot of those pain points right now, and kind of like we've done with TEE, like we've done with a lot of these, hard lessons that we've learned first, just because we were there first. We want to pave a path for, everyone else.
How was Manifold's product here useful to the rest of the BitTensor network? Like, are you guys targeting other subnet teams and going, hey, we can provide this service?
Absolutely. In fact, we are working in some pilot programs with some subnets right now for their verification methods. We're also working pretty closely with Ridges and Dippy as well, and a more on the inference side, and really growing and expanding the types of products that we're offering them, whether that's on inference or going further down the road, whether it's CPU servers on the rental side, or being able to do a lot of different things, right? Some more secret products that will be coming out shortly that we're still trying to figure out on, we're still kind of cooking on, but we want to be a service that can be accessible by not just the Fortune 500, not just enterprise customers, but and self-serve customers, regular consumers like you and me, but also subnets themselves, where they can access this compute and at the most affordable prices with the uptime guarantees that they're looking for. And so we have some people that we're working with right now. We're really excited. And if you're a subnet owner right now, and you're looking to you have GPU validation, or you have CPU validation, or and you're looking to get cut your server bill in half, or in a third, or in half, please reach out to us, and reach out to Matt or James or Viraj, and we'll really try to build something for you. If you need a custom solution, this is also something that we do. We build custom solutions for others because we're a pure software company. Oh, I have a meme actually. I'll post in here, but this is something that we're working really closely with some subnet owners right now, and would love to work with more.
Yeah. If I might add to Cons, one of the things that like I've kind of thought about a lot too as it pertains to BitTensor is decentralized compute is not a new idea. I mean, you outlined this yourself with Golem. Like, there's all sorts of other decentralized compute providers out there. Decentralized compute is actually probably the oldest idea in all of decentralized AI. Now, obviously, we just talked about what makes Targon unique, specifically security, and the Targon virtual machine being kind of like our real, true, technological innovation. But I think that if BitTensor is going to win out as being the decentralized AI ecosystem, then it's absolutely critical that we win at decentralized compute, arguably first, because that will essentially supercharge all the other subnets to then have access to this hyper efficient, liquid, decentralized market where they can access compute at the cheapest prices in the world, which will give them a huge advantage over their centralized competitors. So that is definitely part of our vision, and we, welcome all the subnet teams to come try out Targon.
Oh yeah, I often tell this to teams. I'm like, there's going to be, well, hopefully what we're building here is a stack where we have verification, attestation of the lowest level commodities, and we build layers of assurance from those low levels all the way to applications that we can serve to users, like and famous movie stars like Matthew McConaughey, and give them proper like verifiability, like levels of verifiability up the stack, and incentives. So like we have Plasma blasted here on the call, like he's building a coding agent. Those agents, we can also build a closed source side of his incentive mechanism where the miners don't need to actually make anything public because they can use uh, compute TEE from Targon and say, hey, like this is just an endpoint that's running this service, but we can even attest that it is, looks like this or looks like this code, and here's a hash to prove it. But nobody can see it, and like that's what really gets me excited about this, and ultimately I'm one of the best examples of that. Like I'm running a couple Targon machines right now. Really happy with the CPUs that I'm using. Like they're the best basically you can get, especially for the price, which is incredible. So yeah, it's been awesome to have you on stage. The whole Manifold team, you guys are cracked, and congratulations. I recommend everyone goes to targon.com and tries their latest compute provision and their service and give them some feedback and try to exploit their network.
Yo, yeah, good luck. We will pay out bug bounties. If you find a hole, which I don't think you will, but if you do find a hole, we'll pay you out really well. But come to us first before you wreak
You don't
havoc
need
or
to
something.
pay. You don't need to pay any bug bounties. That's the whole point of BitTensor.
Yeah, that's fair. Well, none of those. We know
Basically-
for sure. We know for sure that they won't be able to get it on the payment side, right? Like they won't be able to spoof GPUs or anything like that. Like that, there's no way. It's cryptographically impossible for them to do that. But like if they find a way into the VM, for example, that's super concerning to us. So and there's no way to monetize that through BitTensor. So we will pay that out. But there's no way they'll get in because, as Josh has mentioned, the VM's encrypted. It's specific to them. We'll know immediately if they do it. I'm pretty sure like it'll trip a lot of wires. But still, if you're, what are they called? What are those kids called? Scattered spider, But I mean, those are just phishing attacks, I guess. There's no legit hackers anymore, man. There's no one doing like rootkits unless they all work for the Israeli intelligence service now.
I mean, I disagree. They are here. Don't be fooled. Maybe they're just not having any luck on BitTensor, but like, so we need to rehire the Mossad. So guys, yeah, what a pleasure. And let's leave it here. Have a great evening.
Yeah, awesome, guys. Thank you so much. Appreciate you hosting us, Const, and letting us come up here.
Anytime. Ciao.